Hey everyone, this is Will here, creator of PBR Painter for Blender. So in this video I want to show you the method that I use to combine normals in PBR Painter. So before I say anything else, if you're not sure what PBR Painter is and you don't know what I'm talking about, definitely check out the description because I'm going to put a link to the introduction video for the add-on and also just a link to where you can get the add-on if you're interested. So the method that I use is actually a mathematically derived method, and I use it because it's very accurate and it's exactly what I needed for the add-on. So I want to show you that, but I also want to show you another method that I like, which is very simple. It's not a mathematically derived method, but it does kind of do a very good job anyway. And it's a really good method if you're very lazy and you kind of want to just do it quickly. It works really well. So I'm going to show you that one first. So what I'm going to do is I'm going to delete the cube for a start, and I'm just going to make a plane, and I'm going to use this to kind of visualize what's happening. So I'm going to jump across to the shading tab, and I'm just going to show you those methods. So let's just have this here to visualize what's happening, as I said. And I'm going to create a new material, and I'm going to be using the normal maps from these different materials here. So I'm going to start with the stone map here, switching to non-color. That looks like this. And I'm going to take a acoustic foam, which looks like this, and I'm going to add the foam on top as an overlay. So what I'm going to do is, the first method I'm going to use is, as I said, very simple. It's literally one node. It's literally a mix RGB node switched to overlay, and just all you need to do is just put the colors in and you're finished. So that's what it looks like. If you adjust this factor, you can go all the way down to 0 overlay, all the way through to full overlay of the two normals. So as I said, really good method if you kind of want something simple and easy. But I also want to show you a much more accurate method, and the method that I use, as I said, in PBR Painter. So before I go through that, because it's fairly kind of involved, I want to give you a bit of background about sort of the reasons why I do what I do, and kind of the maths behind it. So if you're not interested, you can skip this section and jump across to where I do the actual node setup. But I definitely recommend listening because it kind of gives a background of what's actually happening in this method. So what I'm going to do is I'm going to hide this plane, and I'm just going to use a couple of different objects to demonstrate what's happening. So the first thing I'm going to do is I'm going to add in a sphere. I'm going to get rid of half the sphere, so it's a hemisphere. And what I'm going to do is I'm going to say, okay, imagine that this is a normal map. So imagine that you have a normal map that represents this bump. So in other words, you'd have normals going vertical here, you'd have kind of more and more horizontal as you go around in this sphere shape. So let's say you have one normal map like that, and let's say you have another normal map which is a plane. Whoops, I'm going to move it across. So a plane, but it's not a flat plane, it's rotated about the x-axis by 10 degrees. So if you had a normal map like this, you would just have every single normal was just kind of pointing out in that direction there. So let's say you want to combine these two maps. What would be the output that you'd expect? Well, if I just duplicate this, what you'd expect is basically that this one would just be rotated by 10 degrees in the x. So if I go rotate 10x, you get something like that. So this is essentially what the combined normals would look like. So instead of having a vertical here, you'd have kind of this 10 degrees rotation here, and everything would just get rotated by this one. So what's actually happening then is you're taking this normal map and you're rotating it by whatever is going on in this normal map. So you're taking the normals from this and you're looking at how much this map is rotated away from the vertical. So in this case, it's 10 degrees away from the vertical, and you're rotating this one by that amount. You're also needing to know, because it's important later, you need to know the axis of rotation. So in this case, I rotated about the x-axis and I rotated 10 degrees. So I say, okay, take these normals, rotate them about the x-axis by 10 degrees, and I get the final result. You're probably thinking, in reality, there's no such thing as you never ever use a normal map that's just a plane like this, really. What you're more likely to have is a normal map that has normals going all over the place. So more complicated, yes, but in terms of the fundamental process, it's exactly the same. So in this case, we're rotating every normal by this uniform amount. But if you had that set up where you had all sorts of different normals on this map, all you're doing is you're taking each corresponding normal from each map and you're rotating them one at a time. So exact same process, you're just doing one normal at a time. And that's what we're going to do right now with the node setup. So I'm just going to delete these and I'm going to show this one again and jump back in here, and hopefully that made sense. So just to recap, what I want to do is I want to take normal map B and rotate it according to normal map A, or vice versa. And I'm going to go through now the node setup to do that. So what I'm going to do is I'm just going to disconnect this one for a start. And I'm going to give myself some space because it does get a little bit involved, and it requires quite a few nodes to do that. But I'm going to show you that now. So before I do anything, the first thing to note is the fact that this is in a kind of a color space. So it's when you have these normal maps, they're color representations of vectors. So you can't actually do anything until you get this into vector space. So without going into too much depth, what you basically need to do is apply this equation to these colors to get them into vector space. And the equation for that is simply multiply by 2. And again, I'm not going to go into depth about why this is all the case. You can look it up if you want, converting from vector colors to vector normal, not vector colors, normal colors to normal vectors. But this is the equation that you use. So you multiply by 2 and subtract by 1. So what I'm doing is I'm taking every RGB value, I'm multiplying them all by 2 and subtracting 1 from each. And what am I doing? Get in there. Now I'm going to do that to both maps, and then I have both maps in vector space ready to go. Next thing I want to do, in order to do that rotation with a simple mathematical approach, what I want to do is I want to normalize these vectors. And that's going to make the maths really simple, or at least more simple than it would be otherwise. Alright, so now normalize. So that basically means every vector in this map has a length of 1. Okay, so before I go into that rotation, what I'm going to do is I'm going to jump to the end and I'm going to say, alright, so once I do that rotation, I'm going to get one map out at the end, and eventually I'm going to have to convert that map back into color space, because that's what Blender kind of needs to do this, eventually get back to the normals here. So what I'm going to do is I'm going to reverse this equation here, and I'm going to put it at the end. So the way to do that is just to basically reverse the algebra. So instead of subtracting as a second step, I'm going to swap that to the first step and I'm going to swap it to add. And instead of multiplying as the first step, I'm going to put that as the last step and do divide. And I'll just connect these up. And that's basically reversing this. So it's going color space, vector space, back to color space, and then eventually I can add that to a normal map node and I can get my final result. Alright, so now we're kind of getting there. So now we need the important bit, which is how to actually do that rotation that I was talking about. So just to clarify again, what we need to do is we need to take normals from this map and we need to rotate them according to this map. So the way to do that first is I'm going to add a node called vector rotate, which is very convenient because it does a lot of the work for you. And I'm going to connect this first one into vector. So basically I'm saying take these vectors and then do some sort of rotation on them and then spit out another vector at the end. And this vector that it spits out is going to be the combined map that I was talking about. Alright, so now that we've got that, what I'm going to do is I'm going to look at the specifics in here. So I'm going to leave type the same, and axis angle, basically what that means is it's using the exact same rotation system that you'd be used to when you're using Blender. So for example, it requires that you specify an axis, so x-axis for example, and then a number of degrees. So before we had specify x-axis and rotate by 10 degrees. So it's using the exact same approach, it's now just doing them to the normals. So that's exactly what we need. Alright, so the first thing we need to know is what is the axis? So previously, when I gave that example, the axis was just the x-axis. Unfortunately, it's not that simple now because, as I said, we need to know the axis for every single one of the normals in this map. And what it's going to be is it's going to be the axis that normal is rotated away from the vertical. That kind of sounds complicated, and I hope that sort of makes sense, but it's the axis that, if you look at any given normal in here, it's the axis that normal is rotated away from the vertical direction, which is kind of makes sense if you think about it with what I had before. So the way to figure that out, and again, I'm not going to go into too much depth because there's a lot of background theory behind this, but basically what I want to do is something called a cross product. And it's going to be a cross product between these vectors and the vertical. And what the cross product does is it basically tells you the axis of rotation from the vertical in this case. So that's exactly what I said we needed, and that's what that's going to give us. And so therefore what I'm going to do is this is just going to tell us the axis for every one of those normals. So one important thing to do, so I didn't specify this, but what I did here was I basically did 0, 0, 1, which is just a vertical direction. It's just a vertical vector, 1 in the z, 0 everywhere else. One thing that's important to note with the cross product is if you switch the order and do it this way, you'll actually get a different result. What it basically is, if I have a look at this, and I'll show you, it's basically, you can see here, it's like the inverse. So it's kind of, these squares are getting shifted up there. And basically what that's going to do, if you do it the wrong way around, it'll invert your normal map. So basically, if you can either just follow this exact setup that I have here, in which case you'd put this in the bottom one, or you can kind of look at your output and just make sure your normal map isn't inverted. If it's inverted, you would swap these around. But as I said, this setup here works correctly. Okay, so that's the axis done. Now we need to figure out what angle do we rotate these normals. So we're going to follow a similar approach, but instead of doing the cross product, what we're going to do is something called the dot product. Again, I'm not going to go into much detail with that, but basically the dot product, this gives us the axis. Dot product tells us about the angle that it's rotated away. So in my simple example, the axis is x and the dot product, or the angle is 10 degrees. For the dot product, it actually doesn't matter which order you put it in. So that's kind of just how the dot product works. It doesn't matter which way you go. So just bear that in mind. This is almost giving us the angle, but it doesn't actually give us an angle. What it gives us is a cosine of an angle. So in order to go from that to an angle, what we basically need to do is we need to add a vector, not a vector, we need to add a math node. And we need to connect this value into here, and we need to change this to arc cosine. And basically what that is it basically inverts that cosine, and it gets the angle from the cosine. And therefore we have the angle, and we can put that in here. So that's the process, and hopefully it's not too complicated. Hopefully you kind of understood what was happening. And what I'm going to do is I'm going to jump right to the end, and I'm going to have a look. And as we can see, it's done what it should do. So all of this stuff has basically got us to the point where we have this overlay of brick or stone and the acoustic foam. So with that in mind, one thing I will do first is I'll just show you an example. Sorry, not an example. I'll show you the comparison between the two for a start. So this is what it looks like with that overlay method, and this is what it looks like with the vector rotation method. So pretty similar, but you will notice that this is kind of picking up more contrast and more of that detail. In particular, if you look at these, if you look at these edges here, this kind of doesn't really pick up the fact that this is another normal on top of a very steep slope here, whereas this one really picks up and it gives it a really steep kind of normal here. So you can kind of see there that it works a bit better, but what I'll do, actually before I go on, there's one thing that I did miss. So one thing that can happen, because you're doing this vector rotate method, unless you specify a constraint, you can have a situation where you add normal maps and you basically rotate below that 0 point. And obviously that doesn't make sense for a normal map. So you shouldn't have normals that point down, because that's kind of not going to work. And what it's going to do is it's going to give you all sorts of weird results. So what we want to do, after we do that rotate, while we're still in vector form, we want to add another vector math node, and we want to switch this to maximum, and whoops, not normalize, maximum. And what I want to do is I want to basically tell it that for the Z direction, I want to say never go below 0. So what I'm going to do is I'm going to leave that at 0. And what that's going to do is it's going to say anytime a value comes in lower than 0, just call it 0. And that'll stop it rotating less than 0. For the X and the Y, these can be anything as long as they're smaller than -1, because we don't want to put any constraints on the X and Y direction, because they will go from -1 all the way through to 1. So as I said, anything lower than -1 here will work. And basically what that does is it just, as I said, stops it from rotating below 0, which doesn't really happen often, but it can happen theoretically. So it's important to put that in there. One thing I won't go into too much is, so in PBR Painter, you'll notice if you've used it, there's a way to actually, so similar to with this one where you have this factor, you can do that in PBR Painter, and that's because I've added a math node in here. I'm not going to go into that now, but basically the math node kind of acts as this factor, and it lets you control that. So as I said, not going to go into it here, but just remember that there is a way to actually mimic this behavior using this setup. Alright, so that's kind of cool, but obviously very involved. So if you're happy with this, as I said, I do like this method, so if that's enough for you and you don't want to bother with all this stuff, then that's perfectly fine, because this is pretty good and it's going to do a pretty good job. Where this is really useful is when you've got more than 2 normal maps. So what I'm going to show you now is if we wanted to add a third normal map on top of these ones, this one is, because it's very accurate and it's mathematically derived, it's going to retain that information really well, and it's going to maintain that contrast all the way through the normal maps. So with PBR Painter, because you're stacking up multiple layers, that was really important. So that's why one of the main reasons I wanted to use this, because unfortunately, while this is useful, it starts to really show signs of weakness when you add more than 2 normal maps, as I'll show you now. Before I do that, what I'm going to do is I'm going to select all this. Just to simplify things, I'm going to select it all, and I'm going to press Ctrl G, and that's going to group it all into a single node to make it much easier. And if I press Tab now, and I should probably connect that, I didn't connect that up, whoops. So now everything's happening in here, and now it's basically acting as a combined normal thing. Alright, so now that I've got that, what I want to do, so that should be still working, yep. What I want to do is I'm going to add a third normal map, and I'm going to show you how much better this is than this when you have 3 normal maps. So the third one I've got is just this rust, and I'm going to add this because it's kind of a cool looking normal. Whoops. And I'll just show you quickly. So that's what it looks like, and I'm going to add that on top of these 2. So the way I'm going to do that, so in this case I'm going to duplicate this. I'm going to put the output of this one into here, and then I'm going to put the, let's just swap this to non-color for a start. And I will pull this all the way up and into this one. And let's have a look. So as you can see, it's done the combination. So you do have stone, you do have acoustic foam, and you do have that rust. Now I'm going to do it with this method, and I'm going to do the same thing. I'm going to pull the output from this one, and I'm going to put the color from this one into here, and I'm going to show you the difference. So this is that method, this is the mix RGB method. So as you can see, it's really starting to show up that that contrast is really obvious in this one now. It becomes more obvious if I actually use this as a normal map. So let's add in a normal map here and connect up the normals. And I'll put this one in, and I'm just going to change the color to something that's a bit easier to see. Let's just, sorry, let me just so let's make this like a, I don't know, maybe that color. So let's connect up this one. So what you'll see is basically this is now looking really, really, really sort of low contrast with all that normal information. So let's swap it across. And now you can kind of see how much better it is at pulling through all those little bumps. So you've got, clearly you've got stone, it's kind of confusing. It kind of almost looks like it's inverted. I think with all these maps on top of each other, it's actually become hard to see if it is inverted. Is it inverted? I don't think it... I feel like it's flipped in my brain, and now I can't get it back. Let's just have a look at what it looks like originally. Yep, so that's... Is it actually inverted from the start? Or is that my brain playing tricks on me? Yeah. I think it's my brain tricking me into thinking it's inverted. Yeah, anyway. I think because it was upside down, it was looking wrong. Okay. Anyway, let's put that back where it was. All right, so that's the vector method, and this is the other one, the mix RGB. So you can see really it kind of not really a comparison anymore. So that's doing an amazing job of keeping that rust and the foam and the stone all in one. Whereas this one's kind of just blurred it all out, and it's kind of lost a lot of that nice look of everything. And there, so that's basically it. So I think that kind of demonstrates the point. Obviously, as I said, it's fairly complicated, but it is worth it if you're kind of wanting to get that really realistic look, and if you're wanting to combine all of them. Sorry, if you're wanting to combine multiple normal maps, more than two. So in PBR Painter, just to kind of shamelessly self-promote for a second, all of these node groups and that are all built into it, so you don't even need to go into the node tree. So essentially what you do is you have this single button, you click the button, and it just automatically combines all of your normals with what's underneath. So regardless of how many layers, you could have 6 layers, you could have 6 different normal maps, you click a button, it just combines everything together and gives you kind of the combined effects. So really cool, there's so much you can do with that. So as I said, definitely check that out if you haven't already, because I think it's really a powerful tool for creating these complex looking materials. With that being said, I'm going to leave it there. If you like the video, obviously hit like and subscribe, because I've got a bunch of other videos and I'm going to be putting more as I go. Otherwise, thanks for watching. I hope you enjoyed it. I hope you got something from it. I hope it wasn't too confusing and you could kind of understand what was happening, or at least you'll be able to use the node setup that I've got. And anyway, thanks for that, guys, and I will catch you next time. Cheers.